day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patucha Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area Maths and Materials. The topic is atoms, and the subtopic is compounds. Don't forget to send in questions and responses to questions on our WhatsApp line, which is 082-760-2630. You'll see the number up here on the bottom of your screen. Now let's begin today's lesson. Let's look at today's lesson objectives. By the end of today's lesson, you should be able to define a compound, represent compounds as fixed ratios, explain how a compound is formed, explain how a compound can be decomposed, and all of this is sourced from the KEPS document on pages 11 and page 40. Pre-knowledge. This is what we have learned prior to today's lesson, which is actually laying the foundation of today's lesson. In the 7th grade, we learned about properties of materials. We focused on boiling and melting points, electrical conductivity, and heat conductivity. And in the 8th grade, we learned about elements. We learned about the names of elements and their symbols. This is our previous lesson. If you can just go back to our previous lesson, we learned about the different elements that have been discovered and their symbols as well. Now let's do today's baseline activity. I'm going to give you 3 minutes to complete this activity, and then we will go through the solutions together. Okay, learners, now let's go through the assessment together. What is an element? What is an element? An element is a material that consists of atoms of only one kind. So if we're talking about the element carbon, for example, all the atoms that belong to the element carbon will be exactly the same. So that is what we mean. Now, the second question required you to draw models to show the atoms that make up molecules. The first one is oxygen, the second one is water, and the third one is hydrogen. Let's look at the first one, oxygen. So the molecule oxygen is made up of two oxygen atoms. It is made up of two oxygen atoms, and then the water molecule is made up of one oxygen atom and two hydrogen atoms. So that is the water molecule. Let's see the hydrogen molecule. The hydrogen molecule is made up of two hydrogen atoms. Okay, now let's move on to terminology. These are the terms that we're going to be using throughout the lesson. So I feel it's best for us to learn what these mean so that it is easier for us to grasp the concept of today's lesson. The first term is compound. What is a compound? A compound is a material that consists of atoms of two or more different elements that are chemically bonded together. That is a compound. The second term is chemical bond. So the chemical bond is a force that holds atoms together in a molecule. Do you remember in our baseline assessment when we were drawing models of the oxygen molecule, the water molecule, and the hydrogen molecule? So in the oxygen molecule, those two atoms are held together by what is called a chemical bond. So that is the force that is holding both those atoms together, forming that oxygen molecule. And then a chemical reaction. A chemical reaction is a process in which atoms of elements or compounds rearrange themselves to form new compounds or elements. So that is a chemical reaction. So it's a rearrangement. For example, if we are forming the water molecule, there is some kind of rearrangement to form that water molecule. Let's move on to term number 4. What is a hypothesis? So a hypothesis is your idea, answer, or prediction about what will happen and why that will happen. And then decomposition reaction. It is a chemical reaction in which a compound is broken down into a simpler compound or element. And then the last term for today is electrolysis. Electrolysis is the decomposition of a compound when an electrical current is passed through a solution of the compound. Let us move on to today's lesson. We'll start off with compounds. So atoms react chemically to form compounds. Now, a compound, like we've said in our terminology, is a material that consists of atoms of two or more different elements that are chemically bonded together. Here are some examples. We have water. This is a water molecule. It has two hydrogen atoms that are chemically bonded to an oxygen atom. So that is water. Now we have carbon dioxide. Carbon dioxide has one carbon atom that is bonded to two oxygen atoms, and then we have sodium chloride. Sodium chloride, NaCl, has one sodium atom that is bonded to one chlorine atom. So now if we look at this picture that I've just pulled up here, is to just further illustrate your chemical bond. So this is the force of attraction. So now we represent it in the form of a line. So we represent chemical bonds in the form of a line. So that is the force that holds the atoms together, whether it's a molecule or it's a compound. Now, so these are the examples that I referred to earlier. Water, the symbol, the chemical formula is H2O. You make sure that the 2 is small. And then carbon dioxide, the chemical formula is CO2. And then we have sodium chloride. Actually, sodium chloride is salt, the salt that you and I use to flavor our food. We have the chemical formula, which is NaCl. So those are the examples that I've given you in the previous slide. Now let's move on to the next slide. So an atom in each compound is always combined or bonded in a fixed ratio. It is always combined or bonded in a fixed ratio. What do I mean? Let's look at this oxygen molecule. We said an oxygen molecule has 2 oxygen atoms. This is how we write the chemical formula. So it consists of an oxygen atom bonded to another oxygen atom. So now the ratio becomes 1:1. The ratio becomes 1:1. Let me give you another example. A hydrogen molecule. A hydrogen molecule consists of 2 hydrogen atoms. Now, one hydrogen atom is bonded to another hydrogen atom. So it's 1:1. So that is the ratio. Now let's look at our third example, the water molecule. So the water molecule, as we all know, the chemical formula for the water molecule is H2O, meaning that we have 2 hydrogen atoms that are bonded to 1 oxygen atom. So when we write our ratio, we say 2 representing the 2 hydrogen atoms is to 1 representing the 1 oxygen atom. So that is how we write the ratios. Let us move on. Compounds such as water, carbon dioxide, and table salt are formed by what we call chemical reactions. Remember we said, what is a chemical reaction? A chemical reaction is a process in which atoms of elements or compounds rearrange themselves to form new compounds or elements. Now let's look at this example or representation of a chemical reaction. So we have different atoms here and we have different compounds. Now if we check the white, we've got 2 of these molecules and then we have 1 of these. So now in the chemical reaction, these atoms rearrange themselves to form this new compound, these new compounds here. So that is what we mean by chemical arrangement, chemical reaction. There is a rearrangement of atoms of elements to form 2 new compounds. So let's say, for example, we say these atoms are hydrogen and this is oxygen. Now, so these hydrogen molecules react with this oxygen molecule now to form water. Now, do you see what I mean? Let's move on. So now the properties of compounds are different from the properties of the elements that they are made of. What do I mean? For example, if we look at the compound sodium chloride. Sodium chloride is made up of 2 elements. The first one being sodium and the second one being chlorine. Now, the properties of sodium. Sodium on its own has its own properties that are different from the properties of chlorine. And the properties of these 2 elements are also different from the properties of sodium chloride. So what do I mean? For example, sodium and sodium chloride can conduct heat, whereas chlorine does not. You see what I mean by different properties. Now I've got an example here, or rather an illustration of the compound sodium chloride, that is the chemical formula, and it is actually salt. So this is what we see. This is what we see, and this is how the atoms are arranged in the compound. Let's look at the different physical properties of sodium, chlorine, and sodium chloride. For example, the colors of their flames, how they burn. Firstly, sodium chloride burns. Do you see there's a blue flame there? That's how sodium burns. And then we have chlorine. Chlorine burns with a bright white flame, whereas sodium chloride burns with a yellow flame. So you see the different properties. So we can have a compound that has both these elements, but the compound has different properties. It behaves different in chemical reactions. It has different properties, how it feels or how it looks like or how it behaves in different situations. Whereas the elements, the individual elements that make up this compound can also have different properties. Let's do an activity. The first question reads, how are atoms held together in a molecule? The second question reads, the table below shows the different gases that are found in dry air. There's the table. So on the table we have nitrogen, carbon dioxide, argon, and oxygen. And we're supposed to use the table to answer these questions. The first question is, give the name and chemical formula of a molecule of a compound from this table. Give a fixed ratio of elements which make up carbon dioxide. And the third one is give an element that normally exists as diatomic molecules. I'm going to give you 4 minutes to complete this activity, and then we'll look at the solutions together. All right. Do not forget to send in your responses to our question line, which is 082-760-2630. Now let's go through the solutions together. How are the atoms held together in a molecule? And the table below shows the different gases that are found in dry air. That's the table: nitrogen, carbon dioxide, argon, and oxygen. And you're supposed to use the table to give the name and chemical formula of a molecule of a compound amongst these gases in the table. So the first question, the answer is chemical bond. If you wrote chemical bond, you got it correct. And the answer to the second question is carbon dioxide. If you wrote carbon dioxide, you got it correct. The second question is give a fixed ratio of elements which make up carbon dioxide. So which elements make up carbon dioxide? So we have one carbon atom and two oxygen atoms. I'm just going to pull up a picture just to show you. There is oxygen atom 1, oxygen atom 2, and the carbon atom. So that is the fixed ratio. So our fixed ratio becomes 1:2. That is our fixed ratio. Now let's move on to the final question. From the table, select an element that normally exists as diatomic molecules. So you look at these elements here and figure out which element normally exists as diatomic molecules. We have oxygen and we have nitrogen. So their molecule, the chemical formula of the molecule, oxygen becomes O2 and nitrogen is N2. All right, now let's move on to decomposing compounds. Compounds consist of different elements. So we can break a compound down to its original elements either by heating or by electrolysis. Okay, now this process is called decomposition. That is the name of the process. It is called decomposition. So a decomposition reaction is the opposite of what happened when the compound was formed. So remember, when a compound is formed, there's rearrangement of atoms, of elements, and there are chemical bonds that bond those atoms together. So a decomposition reaction is the opposite of that. And I've got a picture here of an example of electrolysis, where we are breaking down water to its individual elements. Now, there are two types of decomposition reactions. The first one is called electrolysis decomposition. And I have a picture here. So this is when we are running an electric current through the solution of the compound to break it down to its elements. Now, so this is an electrolysis decomposition. And then there is heating or thermal decomposition. This is where we heat the compound to break it down to its elements. So those are the two types of decomposition reactions. Let's talk about electrolysis even more. So electrolysis is a process where we are passing an electrical current through a solution of a compound to break it up into other compounds or elements. I gave the example of water earlier, where we pass an electric current through water to break it down to its elements, which is to its elements or compounds, where we end up with hydrogen molecules and oxygen molecules. So electrical energy is used to split up a compound into the element that it is made from. For example, if you pass an electric current through water, you can split it or you can break it down to hydrogen and oxygen. So the electricity breaks the bonds in the water molecules. Remember, we said during a chemical reaction, when a bond is formed, we call this a chemical bond. So electricity is able to break that chemical bond. I have an example here of an electric current being run, an electric current There's a battery here, which is our power source, and the electric current being run through water to split it into hydrogen and oxygen. You see these bubbles there? That is one of the gases that is being released. Now heating, the second type of decomposition. So thermal decomposition is a decomposition reaction where heat energy is used to break down a compound into the elements that it is made of. All right. So the following experiment will demonstrate how potassium permanganate, which is KMnO4, that is the chemical formula, decomposes into its elements by heating. So this is the setup of the experiment that we're going to do. So for now, we're going to take a break so that we go through the instructions of the experiment. Okay, grade 8, don't forget to send in questions and answers to questions on our WhatsApp question line, which is 082-760-2630. So this is the experiment that we're going to conduct today. The aim of our experiment is to decompose potassium permanganate. The hypothesis or the prediction is that when heated, potassium permanganate gives off oxygen. These are the materials and chemicals that we're going to use in our experiment. We're going to use potassium permanganate, which we're going to decompose, a test tube holder, a spatula, and a spirit burner. So this is what we're going to use during the experiment. Of course, we're going to use a wooden splint and matches. This is how we're going to conduct the experiment. This is the method, the steps of the experiment. We're going to place one spatula of potassium permanganate into the test tube. Hold the test tube with a test tube holder and then heat it over a burner. Place a glowing splint on the mouth of the test tube and then record your observations. So those are the steps and the materials of the experiment. Now grade 8, let's go to the lab to do our experiments.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
For this experiment, we're going to need potassium permanganate, a test tube, a spatula, a wooden splint, matches, a spirit burner, and we'll use the stand as our test tube holder. We're going to put 1 spatula of potassium permanganate into the test tube. And then we'll put the test tube and put it into the test tube holder. Make sure you secure it. We're going to turn on the flame now. Be careful of the flame. Make sure the test tube is facing away from you because the experiment releases dangerous fumes. As soon as the flame is on, our potassium permanganate starts to burn. So now we're going to light up our wooden splint. So once most of it is burned, you blow out the flame. Don't blow it all the way out. Make sure that it is glowing. And then you place it into the test tube. Look at that glow. Look at that glow. It shows that there's oxygen being released from the experiment. Now that we're done, we put out the wooden splint fire. And then we switch off the fire for the spirit burner. And then we take the test tube out. And look at that color. The color has changed from the purple to black. Now let's go back to class and analyze our results.
You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Okay, grade 8, I'm sure you enjoyed that part of the experiment. So now let's go through our results. So I'm going to give you 1 minute to record your results. What exactly are you recording? You are recording what you have observed during the experiment or at the end of the experiment. So let us record our results. 1 minute. I hope you sent in your results to our question line, which is 082-760-2630. Let's look at the results together. So first, the compound starts to decompose and the color changes from dark purple to black. So that is the first observation, the color change of the potassium permanganate. It changed from dark purple to black. So that is the first observation. And then the second one, we saw the glowing splint reigniting. So the glowing splint reignited inside the tube. This is actually a positive test for the presence of oxygen gas. Why do we use a glowing splint to show a positive test for oxygen gas? You see, when you make a fire and the wooden blocks are just glowing, but then there's no flame. So what happens when you blow into it? The fire starts. So that is the same concept that we're using to show that there is a presence of oxygen gas. So whenever we record results, we should also conclude our experiment. So can you figure out the conclusion of this experiment? Do your results support your hypothesis? I'm going to give you another minute to come up with a conclusion for this experiment. I hope you're sending in those responses to our question line, which is 082-760-2630. What do you conclude from today's experiment? So when we heated potassium permanganate, it gave off oxygen. That is our conclusion. Let's move on to the questions for the experiment. The first question is, how do you know that there has been a chemical reaction? And the second question is, do you think the reaction will continue if you stop heating the tube? I'm going to give you a total of 3 minutes to answer this question. Please do send in your responses to 082-760-2630. I'm giving you 3 minutes. Okay, grade 8, don't forget to send in your answers to 082-760-2630. So here are the experiment questions. Let's read them again. The first one reads, how do you know that there has been a chemical reaction? And the second one reads, do you think the reaction will continue if you stop heating the tube? Let's go through the responses for the first question. The color of the potassium permanganate changed from purple to black. So if you remember during the experiment, when we were putting the potassium permanganate into the test tube, the color was a dark purple color. And after heating the potassium permanganate, I'm sure you remember when I showed you the test tube, the color had changed to black. So when there is a color change, it is one of the signs that there has been a chemical reaction. It means the properties of that particular compound have changed. And now, one of the signs for that is the color change from purple to black. And then secondly, we know that there has been a chemical reaction because oxygen is released from the test tube, which reignited the glowing splint. This happened when the glowing splint was put into the test tube that contained the potassium permanganate that we're heating, and the glowing splint was reignited and there was a flame. I'm sure you witnessed that bright, that very, very bright yellow flame. Now, remember, one of the definitions, or rather one of the reasons why we say there has been some reaction or a decomposition reaction is breaking down a compound into other compounds or elements that are within that compound. So oxygen, remember when I gave you the formula for potassium permanganate, which is KMnO4. So oxygen is actually one of the elements that make up potassium permanganate, oxygen. So when oxygen was released, then we knew that there has been a chemical reaction, in particular, a decomposition reaction. Then thirdly, how do we know that there's been a chemical reaction? A yellow flame was formed from the glowing splint. So when I put the glowing splint into the test tube, there was a bright yellow flame. So heat was given off during this reaction. So these are the results. So when there is a chemical reaction, you check for the following. 1, you check for color change. Has there been a color change? 2, the oxygen reignited the glowing splint. So there is something that happened there. And then 3, there was a bright yellow flame. So there is heat being released from this reaction. The second question reads, do you think the reaction will continue if you stop heating the tube? Right, let's look at the responses. No. Why are we saying no? The chemical reaction is not going to continue. The chemical reaction is not going to continue because when you stop heating the tube, the formation of oxygen also stopped. Hence, the decomposition also stopped when heating the tube. So the heat here is actually enabling the reaction. It is the catalyst for the reaction. So without the heat, the reaction cannot continue. That is why when the permanganate was not being heated, no oxygen was being released. Now, when the permanganate was being heated, now a gas was released, and that particular gas was oxygen gas, which reignited the glowing splint. So we need heat in order for the chemical reaction to take place. This decomposition reaction needs heat. So without any heat, the decomposition reaction cannot continue. Okay, grade 8. Now, so like what I was saying, you need energy for the reaction to take place. which gives us something to think about. So it means reactions do need energy for them to happen. Reactions do need energy for them to happen. In this particular case, we require heat energy for this particular reaction to take place. Now we have reached the end of our lesson. So let us go through everything that we have learned today. Let's summarize our lesson, grade 8. We'll start off with atoms. What do you remember about atoms in today's lesson? In particular, today's lesson, we learned that atoms react chemically to form molecules of compounds. Do you remember the examples that we gave? We gave an example of oxygen, hydrogen, and water. When two oxygen atoms react, they form the molecule oxygen, which we represent by O2. So now, how are these atoms held together? These atoms are held together by what we call a chemical bond. So usually when we're drawing models of atoms that are bonded together, we use a line to represent the chemical bond. We also learned that atoms in a compound are always combined in a fixed ratio. They are always combined in a fixed ratio. What do we mean by that? Right. Let's look at hydrogen. So two hydrogen atoms chemically react, and then there's a bond, a chemical bond that forms between them to give us our hydrogen molecule, which is H2. Now, if we look at this molecule, it is made up of two hydrogen atoms. This is the first one and this is the second one. So we say that the ratio is 1:1. That is the ratio, 1:1. Same applies to the oxygen molecule. The ratio is 1:1 because if we look at the oxygen molecule, we have two atoms bonded together, atom 1 and atom number 2. So it is 1:1. We also learned about compounds. What did we say a compound is? A compound is a material that consists of atoms of two or more different elements chemically bonded together. So if we look at this compound, water, how many elements do we have? Water is made up of two elements. Hydrogen, they are our hydrogens, and we have oxygen. So we have two elements that are chemically bonded together. Remember we said a chemical bond is a force that holds two molecules, or is it atoms, in a compound together. So these are being held together. So now this is our water. So out of curiosity, what is the fixed ratio for our water molecule? The fixed ratio becomes 2 hydrogen atoms is to 1 oxygen atoms. If you're not sure about the fixed ratio, just count the number of atoms physically, 1 and 2. So those are the 2 hydrogen atoms, and then you can also count the oxygen atom, which is the 1. So we have a ratio of 2:1. We also learned about a special type of chemical reaction, the decomposition reaction. What is a decomposition reaction? Do you remember? You can send in responses as I am going on our number, which is 082 760 263 630. A decomposition reaction. This is where compounds are broken up by decomposition. It is actually the opposite of how compounds in a chemical reaction are formed. So we are breaking down chemical compounds into their elements or other compounds when we are decomposing them. So we can actually do this in two ways. We can do this either by heating, which is method number 1, or by electrolysis, which is method number 2. When we're heating, we call this thermal decomposition or heat decomposition, where we use heat to break down a compound into its elements or compounds. This is a pictorial representation of a decomposition reaction where we are using heat. Here's our heat source. The heat source is the burner. Where we're using heat, we have our compound in there where we're using heat to break down this compound. And then the second method where we can perform a decomposition reaction is by electrolysis. Electrolysis is when we run an electric current through the solution of the compound. What do I mean by solution of the compound? I'm going to give the example of potassium permanganate because it is the chemical or it is the compound that we worked with during our experiment. So with potassium permanganate, picture this. You take potassium permanganate and you dissolve it in water. You completely dissolve it in water so that all of the potassium permanganate has been dissolved. So now that becomes the solution of the compound. So with electrolysis, we run an electric current through the solution of the compound. So think of it as the compound dissolved in water to form the solution. So through the solution of the compound, we run an electric current through the solution of the compound. So when we do this, when we run an electric current through the solution of the compound, the electricity is able to break the chemical bonds that are holding the atoms of the elements together. So the electricity is able to break up or to split those atoms that are bonded together. So then we result with, the end result will be elements or other smaller compounds. If we break down water, the result will be hydrogen and oxygen. Now let's go through the experiment that we conducted towards the end of the lesson. If you remember, the aim of the experiment was to decompose potassium permanganate. We used the following materials. We had a spirit burner, we had matches, a wooden splint, and a test tube holder, a test tube, as well as potassium permanganate. If you remember the method of the experiment, what did we do? Right, we put 1 spatula full of potassium permanganate into a test tube. From there, we took the test tube and placed it on the test tube holder. Why did we use a test tube holder? It is for safety, so that when we are heating, during the heating process of the experiment, we don't burn our fingers. Okay, so when we placed the test tube on the test tube holder, what did we do next? If you remember, we took a spirit burner and we lit it up using our matches to create a flame. So we placed it directly under the test tube. So as the reaction was going on and on, we could hear a popping sound, popping sound. So that was the chemical reaction taking place. That was the potassium permanganate being broken down using heat. So heat is one of the ways, just like electricity, it's one of the ways that we use to decompose a compound, to break up bond between its elements and different atoms. So now, as we were heating the potassium permanganate, what did we do next? We took a splint, a wooden splint, we lit it up, and then blew out the flame to leave that glow, to leave the splint glowing. So we did not completely put out the flame. So we left it glowing. And then what did we do next? We put the splint into the test tube just at the top, and I'm sure you remember observing that bright yellow flame when the splint reignited due to the oxygen gas that it was receiving. So meaning that our decomposition reaction was actually successful. Then the results we got a color change from the dark purple potassium permanganate to a black potassium permanganate, a black color. So the result was a black color. The second result was the reigniting of the glowing splint to show that oxygen has been released from the heating or the decomposition of potassium permanganate. Okay, grade 12, that is a summary of today's lesson. In the next lesson, this is what we're going to be learning. We're going to define what is a mixture, and then we're going to describe methods of separation. I'm checking for WhatsApp questions here. I don't see any. Please do send in your WhatsApp questions even after the lesson has been completed on 082760 and 2630. Thank you so much for joining me in this lesson. Please don't forget to sanitize, wear your mask, and keep social distance. Until next time. Bye-bye.